Welcome to Kairos Training. In the previous session, you learned how to design a semantic model in Kairos. The next step is to process data for the semantic models. First, let us understand, why do we need to process the data for the semantic model? Processing of data for the semantic model is required to create an aggregation layer for the measures and dimension present in the model on top of the source data, so that user queries will be served from the aggregation layer and result in faster responses. This process mainly consists of two subprocesses. One, to read the input source data of the model, and two, to create the aggregation layer for the model. For the purpose of this training, we will refer to processing of data for the semantic model as building the model. So, in this session, you will learn how to build the Kairos semantic model. We will cover these topics in this session: understanding types of data processing, creating data processing schedules, understanding the stages of data processing, understanding the Sparks jobs used for data processing, and understanding data processing summary. Let us first navigate to a semantic model and discuss the types of processing options available. On the Kairos web portal, navigate to the toolbox, go to Semantic Models menu, and then select the Semantic Model AdventureWorks Sales Analysis from the Training Demo folder. Now, click on the Process tab, and then click Schedule Job. Click the Job Type dropdown. You will see different job types, such as Process Full Data, Process Incremental Data, Process Test Data, and Update Aggregates. Full Process Types creates the aggregates for the model by processing all the available data from the source. If you're building the model for the first time, then it is recommended to execute the process with a small set, few partitions, of the fact data to get a sense of the data. This will help you save on building costs and time before finalizing the design. Incremental process type updates or creates the aggregates for the model by processing only the incremental data from the source. Through this process type, you can also replace the already processed data. You can run an incremental process only on a successfully built model. Test process type creates the aggregates for the model by processing the sample data collected randomly from the source. You can define the number of rows for the sample data. You should use this job for initial stage of model testing to get the source data profile and general recommendations from Kairos. Update aggregates process type updates already created aggregates according to the query patterns executed on the model. This improves the overall query response time. You can schedule this process only for a successfully built model. Select one of the process types and then click the Run option to specify when to start the process. In the Run drop-down field, you will see three different options: Now, Once, and Recurring. Select the Now option if you want to schedule the process right away. Select Once option if you want to schedule the process once on a specific date and time. Select the Recurring option if you want to schedule the process to run repeatedly at predefined time intervals. To do so, mention the required start time, end time, build frequency, and so on. Once you select the Run option, click the Schedule button to trigger the data processing job for the model. This data processing job is a series of Spark jobs triggered on a Spark cluster configured for Kairos. Let us schedule a data processing job for the model AdventureWorks Sales Analysis and understand the process with an example. Select the job type as Process Full Data and set the Run option as Now. Click on the Schedule button to trigger the data processing job. To see the details of the job, we will open the Yarn Resource Manager, followed by the Spark Application UI. The data processing job of the model is divided into 4 different categories of jobs, namely Dataset Preprocessing Job, Indexing Jobs, Fact Data Preprocessing Job, and Aggregation Job. Let us now learn about the Dataset Preprocessing Job. This job will be launched only for the datasets of the model where SQL transformation is used. SQL transformation is when the SQL contains the clauses such as joining, group by, where, etc. You can see there is one job named Job of Dataset, Join of Dim Geography, Dim Customer for the dimension geography. For this dataset, we have written a SQL joining 2 tables, Dim Geography and Dim Customer. Sometimes a job might not get executed as per user expectation. In such a scenario, we would be required to debug the job. To see the details of the job execution, click on the job ID. then click on Tracking URL. Now, from the Spark UI, click on the application ID of the job and click on the URL for Job of Dataset, Join of dim geography, dim customer. You will see different stages of the job. Click Stage ID 0. The details for Stage 0 will be shown in 3 sections: the summary metrics, the aggregated metrics, and the task section. The summary metrics of the job highlights the summary level information about the tasks executed. Below this, you will see the aggregated metrics by executor, which shows each executor's information. To see more details about any executor, click on the desired executor ID. In this case, click on STD out of STD error. Lastly, we have the task section. You can see the tasks with their corresponding status as success or running or failed. To debug a task, click on the corresponding host URL. Till now, we have learned how to debug or find the details of the job, job of dataset, join of dim geography, dim customer. Now let's go back to the Yarn Resource Manager and see the second category of job, the index job. Indexing jobs are required to create indexes for the dimension fields used in the model, which would be used for creating the aggregation layer and for faster query processing. Click on Finish to see the jobs completed till now. You can see there are several indexing jobs for the model with the status Finished. Similarly, we can debug the details of each job if required. Let us see the third category of job, that is, the fact data pre-processing job. This job consists of 2 different phases, Level 1 and Level 2. In these phases, Kivos reads the fact table data and generates key value index file, which would be used by the next job, the aggregation job. Similarly, we can debug the details of each job if required. Now let's learn the last category of job, the aggregation job. In this job, Kivos creates the aggregation layer of the model. You see there is a job named Level 3. We call this job as Aggregation Job. Let's see the details of this Level 3 job from the Yarn Resource Manager. Click on the application ID of the job. On the application screen, click on the History URL. This will open the Spark History server. Click on the application ID of the job. Here, you can see that the Level 3 job consists of 3 different types of jobs, namely count jobs, ranges jobs, and aggregation job. Notice that there are 3 count jobs for the 3 dimensions of our model. Each count job is associated to each dimension respectively. Kivos finds sample record count and its size from the output of Level 2 job to get a sense of the data. This helps in creating the ranges of the dimensions. Ranges job. Just like count jobs, there will be 3 range jobs according to the number of dimensions defined in the model. In each of these range jobs, Kivos creates the file size ranges for the dimension as per the dimension sample count and size. This file size would be considered for launching the aggregation job. Aggregations job. This is the last stage of data processing where the actual aggregation layer of the model is created. Inside this job, there are mainly 2 stages: the sort stage and the dimension aggregation stage. In the sort stage, Kivos sorts the dimensions in descending order of dimension cardinality. This will help to launch the aggregation jobs. In this example, we have 3 dimensions: order date, geography, and product, which will be listed in descending order of their cardinality. This means aggregation layer of the order date dimension will be created first, followed by the geography and product dimensions. Now let's learn about the dimension aggregation stage. Dimension aggregation stages will be launched as per the number of dimensions present in the model. In this case, there are 3 stages launched, one in the name of each dimension. Click on the Level 3 job of the ordered date dimension to view the process details. In this stage, Kivos creates the aggregation layer for dimension order date with all possible combination of geography and product. This page will help you to debug and understand how your Spark job for this aggregation layer is performing. If any task is failing or taking more time to complete, Then we will check the STD out of STD error page of the task. Once this stage is successfully executed, then the aggregation stage for the second dimension, geography, will be executed. Let's go back to see the aggregation stage for the second dimension, geography. In this stage, Kairos creates the aggregation layer for dimension geography with all possible combination of product. Click on the Level 4 Job of Geography dimension to view the process details like before. Once this stage is successful, then the aggregation stage for the third dimension, product, will be executed. Let's go back to see the aggregation stage for the third dimension, product. In this stage, Kairos creates the aggregation layer for the dimension product only. Click on the Level 5 Job of the Product dimension to view the process details. Once this stage is successful, the data processing of the model will be completed. Let's go back to the Process tab in the Kairos UI to see the summary of the data processing of the model. Here we see there are a couple of process jobs. Right-click on a process job to see features like Add Notes, Job Summary, and Download Logs. Now click on Job Summary to open the Job Summary page. In this page, we have two tabs, Job Summary tab and Consolidated Summary tab. The Job Summary tab provides the complete information on the current data processing job, including type, time, size, dimensions, fact records processed, and so on. On the right side, you can see a list of subsections such as general information, physical view, partition strategies, etc. for easy access of the desired information. Clicking on each of these sections will show you the details for that section. You can copy the job summary to a notepad by clicking on the Copy to Clipboard icon on the bottom left corner. You can also download the build log file by clicking on the Download Log button and analyze the build summary offline. There's also a Show Job Details URL that lets you access the details of data processing after the build is complete. This information will help you to further optimize the model based on your build SLA and query SLA. We will cover the optimization of the model in a later session. This marks the end of our session on processing data for semantic models in Kairos. In the next session, you will learn how to refine and optimize the semantic models for better performance.